If we look at chemical formulas and want to know how many atoms are in the formula, we can look at the subscripts or the coefficients. So the subscripts, remember, are the numbers below the chemical symbol. So let's say we have glucose, which is sugar. And this is what our cells need to break down to produce ATP in the process called cellular respiration. So let's look at glucose. Okay, if we look at glucose right here, this is the chemical formula for glucose. So the chemical symbol for carbon is C, the chemical symbol for hydrogen is H, the chemical symbol for oxygen is O. So we have carbon, we have hydrogen, we have oxygen. So we can tell what elements are present using the chemical symbols from the periodic table. We can also tell how many atoms of each are present, looking at the subscript. So here we have 6 carbons, we have 12 hydrogens, we have 6 oxygens. So for every molecule of glucose, so for every compound of glucose, we have 6 carbons, 12 hydrogens, and 6 oxygens. Now, if a number does not have a subscript, that means it's 1. So if we have oxygen, but there's no subscript, it's 1 oxygen atom. So you will not see a number 1. Okay. So anything before the subscript, we multiply. So anything in front of the subscript will get multiplied by that subscript. So for example, 4 molecules of carbon dioxide. I want to figure out how many atoms of carbon is that and how many atoms of oxygen is that. Okay, well, we have a subscript of 2 oxygen atoms. We don't have a subscript here, so we know that stands for 1. But we have 4 of them. So we will multiply 4 times each of these subscripts. We will multiply each of the subscripts times this 4. So 4 times 1, 4 carbons. 4 times 2, 8 oxygens. So if I want to count up the atoms in this, I would have 4 carbons, 8 oxygens. 3 molecules of glucose. We want to know how many carbons is that, how many hydrogens is that, how many oxygens is that. Again, we just multiply the subscript. Since it's outside of the parentheses, we're going to multiply times everything in the parentheses by 3. 3 times 6, 18. That's 18 carbons. 3 times 12, 36 hydrogens. 3 times 6, again, 18 oxygens. So if I want to know how many atoms of carbon, how many atoms of hydrogen, how many atoms of oxygen are in 3 molecules of glucose, or 3 compounds of glucose, I would have 18 carbon, 36 hydrogen, 18 oxygen. We also can use coefficients, and coefficients come before the symbol. I have 2 molecules of glucose. I want to figure out how many carbons, how many hydrogens, how many oxygens. So if you think of if these are all together, you think of it as we're kind of multiplying them. So we're going to have 2 molecules of this whole thing. So we're going to have, again, coefficient comes in front of the symbol. To get the number of total carbons, you're going to multiply 2 times 6, so it's 12 carbons. 2 times 12, that's 24 hydrogens. 2 times 6, 12 oxygens. So coefficient, if I have this, I want to figure out how many atoms of carbon, how many atoms of hydrogen, how many atoms of oxygen. First thing I'm going to do, like math, parentheses. Subscript, we're going to multiply this times everything in the parentheses. So 2 times 6, 12. So we have 2 times 12, 24 hydrogen. 2 times 6, 12 oxygen. And we have then, we're going to multiply everything in there by 2. So 2 times 12. In this case now we're having 24 atoms of carbon, 48 atoms of hydrogen, and 24 atoms of oxygen.